Okay, so today we are going to learn about the 3-bit binary counter. Okay, so what is exactly a 3-bit binary counter? So when you look at this diagram, okay, so this diagram is known as a binary counter. Okay, so 3-bit means this 3 bits. Okay, so in this 3-bit binary counter, we are going to learn how to build a JK flip-flop and a T flip-flop. Okay, so we will start with the JK flip-flop. Okay, so first of all, okay, so what are these numbers? Why there are these 3-bit binary numbers on top of these alphabets? Okay, so first, I was given a sequence of numbers from 0 to 7, all arranged in different orders. So according to that, I have written the numbers on top of this. So 0 means 0, 0, 0, 1 means 0, 0, 1. Yeah, so according to that, I've written all the numbers over here. Okay. So now let's start to build a table according to this binary counter. Okay, so this is the binary table for the 3-bit counter. Okay, so first of all, we need to know about the present state and next state. Okay, so guys, what is present state and next state? Okay, let me give you an example of it. Okay. Okay, so present state and next state. So I'll label next state as N and present state as P. Okay, so first of all, this, okay, so we assume that this is your present state right now. So P. Okay, so what is your next state? This. Okay, so if this is your present state, this is your next state. So the numbers that come after another number is known as the next state, and this is your present state. Okay, okay, so now let's look at the table. Okay, so I've labeled it as the present state as Q1, Q2, Q3, next state as Q1 plus, Q2 plus, and Q3 plus. Okay, so for example, let's look at the first one. Okay, let's look at the first one. Okay, so the first one is 0, 0, 0. The present state is 0, 0, 0. Okay, so in this binary counter, this is 0, 0, 0. So what is the next state, which the number that comes after the 0, 0, 0 is 0, 1, 0. So this is known as the next state. This is your present state and this is your next state. So the next state is 0, 1, 0. Okay, let's look at another example. How about 001? Yes. Okay, so 001 is known as your present state, and FFF is 000 is your next state. Okay, so 001 is your present state, 000 is your next state. So according to that binary counter, we have to fill up the table for this present state and next state. Okay, sorry. Okay, so according to the table, according to the according to the binary counter, we have to build a table according to the present state and next state according to the binary counter. Okay, so after building this table, we need to build the JK flip-flop table using the JK flip-flop excitation table. Okay, so this is your JK flip-flop excitation table. Okay, according to this, we're going to build this table. Okay, okay, so for example, so we look at Q1 first, Q1 and Q1 plus. Okay, so the first one is 0, 0. So 0, 0 is 0 and X. So J1 and K1 is 0 and X. So JK flip-flop, there are two inputs, J and K. So that's why we have two, J1 and K1. So so basically this is a 3-bit binary. So we have three, J1, K1, J2, K2, J3, K3. Okay, so let's look at the second one. Okay, we'll try 1, 0. Okay, 1, 0. 1, 0. So 1, 0 means X, J is X and 1. So 1, 0, X and 1. So according to this, you fill up all the table according to the JK flip-flop excitation table. Okay, so okay. After building this table, so our next task is we need to do a K-map. We need to build K-map for each and every one of it, which for K1, K2, J2, K2, J3, K3. For each and every input, we need to build a K-map. So what I've done here is a K-map for all of the inputs. Okay, so for example, let's look at J1. So this is the K-map for J1. So here we have chosen SOP. SO. Okay, so SOP means 1. Okay, so X here denotes as don't care, which means when you circle 1 and X, which means X is denoted as 1. So okay, so according to this K-map, we only have one circle. Okay. Okay. Well, in this K-map, okay, so we're gonna build the equation for J1. Okay, let's see how do we do that. Okay, so first is 0 and 1. Okay, so we look at this, which is the left side. The left side 0 and 1. So Q1 is in the left side. So 0, 1, 0 and 1 means we don't write Q1 here. How about this? 1, 1 and 1. So we write Q2 and Q3 is at 0. So we write this as Q3 prime. Okay, let's look at the second one. Okay, let's look at the second one, which is, yep, okay. So this is a XNOR gate. Okay, so maybe you guys have studied before. So we learned, you guys have to know how to simplify the equation. So this is a XNOR gate. Okay, why this is an XNOR gate? Okay, so let me tell you. Okay, so for Q1, let's look at this, the left side, 0, 0. So this is Q1 prime. Q2, which is 0 and 1. So we do not take Q2. So how about Q3? So for the first circle, Q3 is 0, so which means is Q1 prime and Q3 prime plus bit. So since it's a SOP, you plus this one, Q1 and Q1. Yeah, so this is 1 and 1. So which means it's Q1 and this is 1, so it's Q3. So the equation is Q1 prime, Q3 prime plus with Q1, Q3. So that's how you get the XNOR gate. Okay. So I think, so this is known as the XOR gate. Okay, there are difference between XNOR and XOR gate. Okay, so XNOR gate, there is a bar here, and XOR gate, there's no bar. So please take note of that. Okay, please take note of that. Okay, so according to this K-map, I have built all the equations for J1 until K3. Okay, so now we're going to look at the JK flip-flop circuit. Okay, now this is the JK flip-flop circuit. As I said, J1, K1, J2, K2, J3, K. So there are 3 because it's a 3-bit binary. Okay. So okay, let me teach you how to build this circuit. Okay, let's use a different color. Okay. Okay. According to this, okay, J1 is Q2 and Q3 prime. So okay, J1, so Q2, input from Q2 and Q3 prime. So input from Q3 prime. So since it's an AND gate, so you use this AND gate, and the input is transferred to J1. Okay, let's look at another one, which is okay. Okay, which is J2. Okay, J2 since it's an XNOR gate for Q1 and Q3. Okay. So okay, so Q1 and Q3, right? Okay, XNOR gate for J2. Okay, so you guys need to take note that J2 and Q2, the inputs are the same, which is Q1 and Q3 XNOR gate. So Q1, Q3, XNOR gate. This is the XNOR gate. So your input is for J2 and K2. So please take note of this. Guys, please take note of this. Okay, so now let's look. Okay, so this is your JK flip-flop. According to the K map, you build this JK flip-flop. Okay, so now let's look at the T flip-flop. Okay, so the process is the same. It's just that this time your input, you should be careful with your input, because JK, there are 2 inputs, but T only 1. So you only do T1, T2, and T3. Okay, so as I told you just now, Q1 plus, according to the T flip-flop excitation table, according to the T flip-flop excitation table, you fill up T1, T2, T3. Okay, for example, 0, 0 means 0, so 0. So Q1, you have to look at Q1 plus, and you fill up T1. Okay, yeah. So that is your T flip-flop excitation table. Okay, so now, so the next slide is. Okay, so now, okay, so okay, after building the T flip-flop excitation table, you're going to build the K map, same process as the JK flip-flop. Okay, so we are going to choose SOP, the same thing. So according to that, you're going to build the equation. Okay, so let's take note that there is another XNOR gate here. Okay, in T2, there is another XNOR gate here. Okay, how about this? Yeah, there's another XNOR gate here. So, okay, let's look at the T flip-flop. Okay, so there's an XNOR gate here. Okay, let me give you an example. Okay, so T2 XNOR gate Q1 plus Q3. Okay, let's look at, okay, Q1 plus Q3. Okay, so for T2, XNOR gate is Q1 plus Q3. So Q1 and Q3. So this is the XNOR gate. Okay, so according to the K map, you build your T flip-flop circuit. Okay, guys, I hope you understand what I've taught you all today. Do more exercise so you can get familiar of how to build the circuit. Thank you.